Hello everyone. Hi, this is Dr. Tithi Banerjee, Assistant Professor of the Department of Civil Engineering of Swami Vivekananda Institute of Science and Technology. So students, today I will be delivering lecture on minerals, its identifying physical properties, its importance, and moreover, most importantly, its role in civil engineering. All the aspects will be discussed here. So let's start the class. Now, before going to what is mineral, I will give you a brief idea of mineralogy. Mineralogy is an important important branch of earth science or geology. Now you will ask me that what is geology or earth science? Earth science and geology is nothing but understanding of earth surface processes. So, to understand the Earth's surface processes, we need to know that what is the main composition of Earth. Earth mainly composed of, we all know that, rocks, soil, and water. And now, what is mineralogy? Mineralogy is nothing but a subject which deals with minerals. Minerals are the smallest unit of a rock. Now, what do we mean by smallest unit? Just like atom, mineral are the smallest unit. We all know that atom is the smallest unit of an element which is electrically neutral. Same as mineral is the smallest unit of a rock. Now, before going to mineral in a elaborate sense, I will discuss the role of mineralogy in the field of civil engineering. I will definitely say you all that mineralogy plays a very crucial role in various aspects of construction projects. By understanding the mineral composition of rocks and soils, engineers can easily assess their engineering properties and make important decisions regarding their suitability or vulnerability for construction. This article or this lecture will explore the key concepts and principles of mineralogy in civil engineering. We will discuss its real world application and highlight its advantages and disadvantages. Now, mineral have both physical and optical properties. For regarding the optical properties, I will discuss all the optical properties in the next lecture. As of now, we will concentrate on the physical properties of the mineral. Now, what is physical properties? Physical properties is nothing but the properties which can be studied in naked eye or in hand specimen. So the properties of a mineral which can be studied physically without testing any laboratory in naked eye are known as physical properties. I am not saying that physical properties are very definite, but definitely we will get a preliminary or a basic concept of any mineral in field study or in hand specimen. So physical properties are very important because it gives us, because we can move our laboratory everywhere, especially in the field. We civil engineers are field engineers, so we can always take our laboratory with us. So to develop a basic concept of a mineral, we need to study the physical properties. Now, coming to what is mineral. Now, in one sentence we can say you that mineral is a homogeneous atomically definite substance which have a regular atomic structure, definite chemical composition, and most importantly, it is naturally occurred. Why natural occurrence is very important to understand mineral? Because minerals, we can name a particular substance as a mineral when they naturally occurred. Now I will give you an example. That is a piece of wood or a biscuit. a piece of wood cannot be considered as a mineral. Now you will ask me why? Because a piece of wood has a definite chemical composition, but it lacks definite atomic bonding. Though it is naturally occurred, but because it doesn't have a definite atomic bonding, definite atomic size and shape, that's why wood cannot be considered as mineral. Same with the biscuit, because we all know that biscuit also have a definite chemical composition, but it is not naturally occurred. So biscuit cannot be considered as a mineral. So in 2 or 3 sentences, if we define mineral, we can say that a mineral or mineral species is a broadly speaking a solid substance with a well-defined chemical composition and a specific crystal structure. What is crystal structure? If a substance has a definite atomic bonding, it will clearly have a definite crystal structures and which are naturally occurred. Now, mineral can be biogenic, mineral can be non-biogenic. Now I will give you an example of a mineral which is biogenic, that is calcite and quartz. There are several types of minerals and several kinds of minerals. I will give you some names, such as I have told you that calcite is a biogenic mineral, same as quartz is not a biogenic mineral. So mineral can be biogenic, mineral can be non-biogenic. But whatever may be the source of its origin, mineral should be naturally occurred. It will have a definite chemical composition with definite atomic bonding. So, in a nutshell, this is the basic concept of a mineral. Now, moving to the next slide, I will tell you the impact of minerals on engineering properties. As I told you that mineral possess physical, chemical and mechanical properties that can influence the engineering properties of rocks and soils. How? How? Because the strength of a mineral can really define the strength of a rock. So as a civil engineer or a strength of a soil substance. So as a civil engineer, we must know the strength of a rock or a soil. So to know that, we need to know that the strength or hardness of a mineral. So I have told you in my previous slide that in this particular lecture, we will discuss the physical properties of a mineral. So there are several kind of physical properties. That is hardness, that is strength, that is color, that is luster, that is strength. All the physical properties I will discuss elaborately. But now in this particular slide, I am just telling you the names of the physical properties. Now, going back to the next slide. As I told you that mineral rock constitutes mineral. So the mineralogical composition of rocks and soils has a significant impact on their engineering behavior. Different minerals exhibit varying degree of strength, deformation characters, weathering resistance, and erosional capacities. Understanding the common minerals found in rock and soils and their characteristics allows engineers to assess the suitability or vulnerability of these materials for construction projects. Because if we don't know the strength of mineral, the kind of mineral which is constituting a rock, we will not be able to determine the actual strength of rock, because minerals are the main constituents of rocks. So it is very important to study the minerals. Now, moving forward to the next slide, I have told you that color is a physical properties of mineral. Now, with the help of color, we can have a very gross, a minimum idea of how the mineral look like. So I'm not saying by identifying the color you will have a very good idea of the mineral, but definitely it will help you to some extent to identify how the mineral look like. So in the earth surface there are several kind of minerals. I'll give you some examples, such as I have already told you that quartz is the major important rock mineral. Now, what is its color? Its color is white or rosy pink, pinkish, grayish, blackish. These are the color variety of quartz. So, on the basis of the color in the field, we can have a very basic idea of a mineral. Now, if we see the next slide, we'll see that we there are two photograph of minerals given. The left side can be identified as quartz, which is purplish white in color, and in the photograph of the right side mineral is a fluorite. So quartz and fluorite both are important, but quartz is the major rock forming mineral because it is composed of silica. So in the earth surface, majority of the rocks are composed of mainly of silica. So silica is the major rock forming element. So we can definitely say that quartz is the major rock forming mineral. So every quartz, fluorite, calcite, gypsum, hematite, magnetite, chalcedony, there are several kind of minerals. But you must know that every mineral has a important engineering as well as economic aspect. So now different minerals have a different color, such as I have told you there are the two examples of minerals that are quartz and fluoride. The that Another important mineral is calcite, because we all know that cement is mainly composed of limestone. We can derive cement from limestone only, and limestone is nothing but composed of calcite. So calcite is a very important mineral, and it is biogenic also, but it looks like a white color crystal. The color of calcite in field area is white. Now, another important feature is luster. Now, what is luster? Luster is nothing but a physical property of a mineral which depicts the reflection of light. So, different minerals have different kind of luster. Now, I have already explained you that quartz is an important rock forming mineral. Now, what is the luster of quartz? We will tell you, but first of all, you understand that what is luster. Luster is nothing but a property of mineral which depicts reflection of light. Quartz has a vitreous luster. Okay. Now, what is vitreous luster? Because we all know that quartz is translucent. Some of the light through quartz can get reflected, some of the light can get absorbed, some of the light can get refracted. So quartz exhibit vitreous luster. Now several kind of luster is there. Luster mainly broadly categorized into two categories. One is metallic luster, another is non-metallic luster. By the name you can understand that metallic luster represents shining. That's represented by metallic luster, and non-shining luster is known as non-metallic luster. जैसे suppose metallic luster, I will explain you. I have just few minutes back I have told you that there are two minerals which are also important, that is hematite, magnetite, which are generally ore minerals. What are old minerals are commonly found beneath the earth in the ore, in the form of ore. The hematite and magnetite are common. Very interesting to know that hematite and magnetite are common ore minerals of what? That is iron. So hematite have a metallic luster, whereas graphite, we all know that graphite, which is by which that all the pencil lids are made. So graphite has a non-metallic luster, right? Whereas coal has also a non-metallic luster. Now here we can see that the left side picture is of hematite, which is giving a very metallic shining appearance, and the left side of the mineral is also, and this is the photograph of chalcopyrite, which is the old mineral of copper, which is also giving a very shining appearance, that can be identified as metallic luster. Now this picture, non-metal, now we will come to non-metallic luster. This picture represents a luster of quartz. It is shining, but it is not shining like a metal. So this is non-metallic luster, but it is the luster of quartz, which is also known as glassy luster or quartzy luster or vitreous luster. Now non-metallic luster, we will see that the luster of pearl, the luster of graphite, the luster of coal, the luster of gypsum, the luster of talc, all are the non-metallic luster, which is not at all have a very shining appearance. So I think you all understood about luster. Now there is a typical luster of which I have told you about gypsum. Gypsum is a very important mineral because it always helps us to disinfect water or any liquid. So gypsum has a very silky kind of luster. So the luster of gypsum is defined as silky luster. So these are the few example of non-metallic luster. Bauxite, aluminium ore, it has a earthy luster. It is not shining, that's why it has been defined as non-metallic luster. These you can see have a shining appearance. It is showing a shining appearance, but not shining appearance like a metal. Excuse me. So this is also identified as non-metallic luster. So now in these two picture you will see that there are two kind of luster. Left side, the luster of the left side minerals is known, it's shining, it's giving a metallic sheen. This is the luster of hematite, but in few cases hematite can give you also a dull luster when it is very much weathered, because oxidation results in giving a very dull kind of appearance. So hematite can give both the lusters, metallic as well as non-metallic. So now in the next slide, so in the lab also, we in the preliminary study, we first of all distinguish the metallic lustrous mineral or non-metallic lustrous mineral. This is a very basic preliminary idea we will get by studying of luster. Now Another important physical properties, this is also an important physical properties. All the properties you are saying, that you are observing, that all can be studied in naked eye. It will not give you a definite, very definite or very particular idea of a mineral, but definitely will give a basic or preliminary idea of a mineral. Now streak streak is the color of a mineral powder, which is studied by getting scratched, or by getting scratched by nail, or by getting scratched on a porcelain tile, that is called a streak plate. Now you all can ask that why streak is necessary, because we are already studying color. No, here is a here the, this thing can create confusion, because there are various kind of minerals which exhibit same color, but both the mineral which are exhibiting same color are different mineral. How we will identify? We will identify by studying the properties of streak. Because mineral powder, suppose quartz and feldspar, both give a very white, glassy color. Feldspar and calcite, both the color are white. But if we study the streak color, what is streak color? That is the color of the mineral powder, which we can get by scratching by nails, or scratching by a porcelain tile. The porcelain tile is generally called streak plate. So what I am telling you, that both calcite and feldspar, both are white in color, but when we will study the color of the mineral powder, we will see that there is some difference, because calcite will give you a powdery white color, and whereas feldspar will give you a flesh color. So streak, that's why is very important, because there are several kind of mineral which are same in color, but when we will form a powder of that mineral, we will get different color. So streak, that's why streak is important. Now, another important, very important properties is hardness. Okay, what is hardness? If we study, determine the hardness in lab of a mineral in lab, we will study or determine the compressive strength, okay, or the tensile strength. But as I told you, that we can't get laboratory everywhere, because especially in the remote field areas, we need to have a preliminary idea of the mineral on field only. So that's why physical property is important. Now hardness is a very important physical properties. It can be determined in naked eye also, but it will be more precise if we will determine it in lab. But in field, as we don't have a laboratory readily, so we will have a gross idea of hardness in the field only by using Mohs scale of hardness. This is important. Now, hardness in a sentence, if we describe what is hardness, hardness is nothing but a mineral's resistance to being scratched. Right? Now, a German geoscientist, Friedrich Mohs, had invented Mohs scale of hardness. This is a very ordinary scale, because with this scale we will not get a very definite idea of strength or hardness, but we will have a very very, I will not say that very clear picture of hardness, but we will have a basic idea. So he invented a scale, and he categorized several mineral on the basis of hardness on a scale of 1 to 10. Now we will come to the scale of Moho. Now, according to Moho, diamond is the hardest mineral and talc is the softest mineral. So, diamond, we all know that. And what is talc? Talc is a very important mineral. Talc is used in soap, in washing powder, okay, in talcum powder. Talc is a very soft mineral. Now, I will describe the Moho scale of hardness. So, what I have told you that it is a very comparative scale. It is a very ordinary scale. But on this basis of on this scale of Moho, we'll definitely have a very preliminary idea of hardness. So, according to Moho, Moho had rated different kind of minerals on the basis of 1 to 10 scale. Now, the softest mineral according to Mohs scale of hardness, that is talc, and in laboratory also we have tested that the compressive strength of talc is very low. Now the softest mineral talc, then comes under gypsum, which hardness is 2, then comes on calcite, wood hardness is 3, then comes fluorite, wood hardness is 4, then comes apatite, which hardness is 5, then comes orthoclase, which hardness is 6, then comes quartz, that is the most common rock forming mineral, whose hardness is 7, then comes topaz 8, and then 9, and then ultimately 10. So diamond is the hardest mineral. And if we study this strength in laboratory also, we'll see that diamond is the hardest mineral. So Moho scale, I'm not saying that Moho scale is a very definite scale, but definitely we'll get a basic idea of hardness. Now, there are few examples of hardness. That is, the hardness of glass plate is 5.5, iron nail is 4.5, copper penny is 3.1, fingernail hardness is 2.5. So these are the some hardness of few minerals. Now you understood what is Mohs scale of hardness. So all these physical properties are very important, and I have described you why. Today I will be in hardness also we have a, in lab setup also we have a definite, we will rate the mineral on the basis of Mohs scale. We will compare it. There are several lab setups also. Now in this class, in this particular class, we have described all the, not all the, few physical very important properties of mineral. In the next class I'll discuss the rest of the properties. As of now, just go through it and read carefully, and thank you for your patience, and thank you for listening the whole class. Thank you.